Hello everyone, my name is Tushar Singh and today I'm going to demonstrate you uh, a very powerful supervised machine learning algorithm which can be used to solve both regression as well as classification problem very effectively, and that is decision tree. Now for the purpose of this task I will use iris dataset like like I've used before. So the main purpose here for this task is to build a decision tree classifier model and use that model to predict the right class of any new data. So here new data will be our test data, and we're going to predict the right class of our test data by using the decision tree classifier. All right. So let's first import some basic libraries like pandas, numpy, and matplotlib. Okay, so we have imported our libraries. Now let's load our data set. Okay, so let's browse our data set. Okay, so let's see the first five observations in our data. Okay, so as you can see, our data has six different columns: ID, sepal length, sepal width, petal width, and species. Right. Now let's see the shape of our data. So our data contains 150 rows and 6 columns. Now let's see if our data has any missing values or not. So as you can see that our data is clean and there are no missing values in any of the columns in our data. So that means that we don't have to do any kind of data manipulation or data cleaning process. Okay, so now let's segregate our data set into two different variables, x and y. X being the independent variable and y is the dependent variable. So here I've taken species as our dependent variable. And the simple reason behind that is because decision tree is a used for both classification and regression, but here we are solving a classification problem. So in classification, we have to classify our data based on the target variable, and target variable should contain the categories, right? The categories based on which we can classify our data easily. So that's why I've taken species as my dependent variable, because species contains only categorical variable, or you can say classes. So uh, so I can use those classes as categories, and based on that I can easily classify my data set. So I hope it's clear now. So let's segregate our data. So it's done. Now let's import train and test split helper function from sklearn. Okay, so it's imported. Now let's create train and test set by using train test plate method. And under train test plate, uh, I've passed different parameters like x and y. X and y, dependent and independent. Independent and dependent variable. Random state, I've taken a value of 101. So random state basically ensures that whenever we run this code in future, any number of times, we will get the same output, right? So you can set any integer value here. It can be 0, it can be -1, but it should be an integer. It can't be in fraction. And stratify is the validation technique. So what stratify basically do is to ensure that the distribution of our target variable is same in our train as well as in our test set, right? And test set means the how much size we want for our test data. So 0.25 means that 25% of values will be in our test data and the remaining 75% values will be in our training data. So let's run this cell. Okay, so it's run. Now, let's see the uh, values in different categories in our train Y set by using value counts function. Okay, so now you can see that in train Y data set, Iris Virginia category contains 38 values, and the rest Iris versicolor and Iris setosa contains 37 values each, right? Now let's normalize our data in the train Y data set. Okay, now similarly normalize our data in the test set. Okay, so now there's a very important point. Now you can see that the distribution of our target variable, which is species column here. So the distribution of species in both train as well as in test set is same in each of the categories. So the distribution of target variable species in this Iris virginica category is around 34%. And similarly in test set, the distribution of species in Iris setosa category is also around 34%, right? Similarly, you can check other categories also. In Iris versicolor, the distribution is same in both train and test data set, almost around 34%. So that's the main use of using stratify validation method. It ensures that the distribution of our target variable is same in both train and test data set, right? So let's move ahead. Now let's see the shape of our train and okay, so let's see the shape of our training set. Okay, so our training set contains 112 rows and 5 columns, right? And this is the dimension of our of columns of our target column in train Y data set, and this is the shape of columns in the train X data set. Now, similarly, let's see the shape in our test set. So our test set contains 38 values only. So which you can guess because 38 is the 25% of our whole data set, right? So our test set contains 25 values and the remaining 75%, which is 112, is in our train set. Now let's import decision tree classifier helper function from sklearn.tree package. And now let's create our decision tree classifier model. Here I've passed only one parameter, which is random state. But later on, you can see that we can change any number of parameters as per our own need. So let's run this code. Okay, so now let's train our decision tree model by using train X and train Y. All right, now as you can see that there are different hyperparameters. So these are called hyperparameters: class weight, criterion, max depth. So all these are hyperparameters, and we can change the default values of these hyperparameters as per our own need, which we will use later in our code, right? Now let's see the score of our decision tree model on training set. So you can see that the score is 1, which means 100% on our training set. Now, similarly, let's see the score on our score of our decision tree model on test set. So again, the score is 100%. So which means that our model is trained very effectively and in a very rightful manner. Now let's uh, get the predictions on our test set by using dot predict helper function. So these are our predictions, right? Which are stored in the form of arrays. So prediction are basically the categories of our species column, right? Now let's better, visualize this by using value counts. So value counts will give us which values in each of these categories in the predictions that we have got earlier. So now you can see that in iris versicolor category we have 13 values, and similarly iris setosa and iris virginia contains 13 and 12 values respectively. Right now let's see the probability by using predict underscore proba function on test set. So so the main use of predict underscore proba function basically is to uh, give us the probability of each values in our test set. So that probability uh, tells us that to which class that particular value belongs to. So in this case, there are 38 different values because we have 38 values in our test set. So here, like our first value, which is an array, tells us that the first value belongs to the second class, which is this iris setosa category. Similarly, our second value tells us that second value belongs to our third class, which is iris virginica. So similarly, you can interpret the rest values also. And also one more thing, that sometimes the probability contains fractional values like 0.7, 0.7, 0.8, 0.75. So in that case, we have to introduce one threshold value above which the probability will be 1, below which it will be 0. So because we have to introduce threshold because we can't classify our data set based on the fractional probabilities. So we have to get probability only in the form of 0 and 1, right? Okay, so let's proceed ahead. So now let's import the accuracy score to check the accuracy of our model from sklearn. Okay, so now in this code, basically I've created two different empty lists, right? Each list contains the accuracy. So train underscore acc list will contain the accuracy of the training set, and val underscore acc list contain the accuracy of the validation, or you can say test set. In this set, I've taken the range from 1 to 10, which denotes the depth of my decision tree. And then I've created the decision tree model here. And under max depth parameter, I've passed I, which is this I values for the range 1 to 10. And I've set the random state as 10. Then I train my model based on training set, and then I append the score on both training and test set to their respective list, right? So I've appended the training score on the train underscore acc list, and I've appended the validation score on the val underscore x list. So I hope it's clear now. Okay, so it's this one. Now let's create the data frame, which contains three columns: maximum depth, which indicates the depth of the decision tree from 1 to 10. Train accuracy shows the accuracy of our training set, and similarly, validation accuracy shows the validation of our test set. Okay, so it's created. Now let's see the first five observation of our data frame. So you can see this indicates the depth of my decision tree, and this indicates the corresponding training and test accuracy. Now let's visualize this thing in the form of a simple plot from matplotlib. Okay, so here you can see that on x-axis we have the depth of our decision tree, and on the y-axis we have the performance, basically the accuracy score. And there is one very interesting thing, which is when the depth of the decision tree is 1, the training and validation accuracy is somewhere around 67%. So training accuracy is higher than the validation accuracy. But when the depth of my decision tree starts increasing, the training and test accuracy remains constant at 1, or you can say 100%, right? So no matter how long or how lengthy my decision tree is, the training and test accuracy will remain constant at 1, which is a good thing because sometimes it's not very easy to achieve 100% accuracy. Okay, so now let's again create our decision tree classifier model. And now this time we will change some of the hyperparameter values. So here I've changed the depth of my decision tree to 8 and number of my leaf or terminal nodes to 25. So let's create our model. Now let's train our model. Okay. Okay, so here I've by default taken the test set. So let's change to training set. Train X and train Y. Okay. Okay, so our model is trained on our training set. And you can see now the hyperparameter value for max depth and max leaf nodes are changed. So max depth, where is it? Okay, so max depth becomes 8 now, and max leaf node becomes 25, which is 20 terminal nodes. So maximum terminal nodes our decision tree can have is 25. Okay, now let's see the score of our decision tree model on training set. So as you can see, it's again 100%. Now let's see the decision tree model score on test set. It's again 100%. So which is a good thing because uh, this means that our model has no underfitting or overfitting issue. So let's say if your training score is more than your test score, that means that you have an overfitting issues. That means your model trained well on your training set, which is your scene data, but it will not predict as accurately as you want on your test data, which means your model simply just memorize the relationships between the data on your training set. And when the score is low in both your train as well as your test set, that means you have an underfitting issues, which means that your model uh, didn't learn anything at all. So an optimal score or best fit score is something which have a similar values, similar high values in both train as well as in test set. Okay, so let's move ahead. Now let's import some libraries like GraphBase and Tree, which basically used to visualize our decision tree. Okay, so let's import this. All right. Now let's use tree helper function and use export underscore GraphBase function. And under this function, I've passed different parameters. So DT model is our decision tree model. Out file indicates the decision tree file in the default format. So default format is dot format. Feature names, basically the column names. Okay, so it should be my train X columns, right? And maximum depth is the depth of my decision tree. And filled is also one of the parameters. So we will discuss about this fill parameter later on when we will visualize our decision tree. So let's run this code. Okay. Now let's convert our decision tree from the default dot format to .png format. All right. Now finally let's visualize our decision tree using image show function from matplotlib. So you can see that our our uh, newly format of our decision tree is .png. Okay, so this is our decision tree, which is created on the training set, right? So as you can see in the first node, we have 112 samples, out of which 37 belongs to the first category, 37 belongs to the second category, and the remaining 38 to the third one, which split further into two different binary splits. In the first split, we have 74 samples out of 112, and the remaining 38 belongs to the second split. And out of 74, 37 belongs to the first category, 37 belongs to the second category, and none to my third category. Now here, all my 38 values belongs to the third category. That means that this node is a homogeneous node. So homogeneous node basically is that node which contains all the values belongs to the one particular class. So this node is called homogeneous because all the 38 categories belong to my third class, which is I think Iris Setosa, if I'm not wrong. But here this node is not homogeneous because here both the values belongs to two different classes. So it is a heterogeneous one. That's why it split further into two different nodes, and these nodes are homogeneous because here all the 37 values belongs to only one particular class. And similarly here, all the 37 values belong to the second class. So this is how we classify our data into different classes using decision tree. So the point that I'm mentioning earlier is this field is equal to true. So the main purpose of field is to show this colored cell, which are our you can say the classified cell. So if we by default keep it at false, then in that case we don't get our classified nodes in colored form, like in blue, green, and orange. So when we said field is equals to true, that In that case, we get our classified or final classified nodes in colored form, which can highlight or visualize our uh, final created nodes, classified nodes. So this is how we classify our data using decision tree. But the thing is that our main purpose is still not yet complete, because our main purpose is to predict the class of our data set based on the new data. Here we predict the class based on the training set, and training set is not the new data, is the that training set is the seen data. Our model already seen that data. So that's why now let's check our model by using test data, because test data is our new data, is the unseen data. And let's see whether our model predicts the right class for our test data also. So I have to make some changes here. So here I've trained my model on on my training data. Instead of my training data, I have to pass my test data. So my test data is val x and val y. So let's pass my test data. Now let's run this code. Okay, so now I've trained my model on my test data. Let's again see the score. Okay, so now as you can see, the score of my decision tree model on train set is decreased to 0.93. Now let's see the score on our test data. So you can see the score on our test data is higher than the score on our training data, which is a good thing. That means that we don't have any overfitting issues. Overfitting means when our score on our training test data is higher than our test data. Okay, so let's again run this code. Okay, now here I have to use val x, which is our which is our test data columns instead of our train data columns. And let's run this code again. Okay. Now let's again convert our decision tree from dot format to PNG. All right. Now let's finally visualize our decision tree on test data. Okay. So now you can see this is our decision tree, which is trained on our test data. And as you know that our test data contains only 38 values, that is 25% values. So out of 38 values, 13 belongs to the first category, 13 to the second, and the remaining 12 to the third one, which further splits into two binary split, where in the second node, all 13 values belongs to the first category. That means it is a homogeneous node. That's why it is colored in orange. And in this third node, which contains 25 values out of 38, 13 13 values is in my second category and the rest 12 in my third, which means that it is not a homogeneous, because not all the values belongs to the any particular class, which means that it will split further. So that means when it's split, 13 values is in our last leaf node, and all 13 values belongs to the second category. And similarly, our second leaf node, terminal node, contains 12 values, and all 12 values belongs to our third category. That means this, and this are our finally classified homogeneous pure nodes. So that means that our decision tree model can classify any new data perfectly, and it is also able to predict the right class according to the data. So I hope you enjoy this uh, very simple demonstration of how we can classify the data set based on uh, decision tree algorithm. I know it is somewhere lengthy process than other classification algorithm, but today nowadays decision tree is the most powerful machine learning algorithm, and it has used in various different applications like credit risk, loan default, you know, uh, similarly for checking the employee churn, customer attrition. So that's why it is considered as one of the most powerful classification algorithm. So thank you very much for watching this video, and I hope you will get the right insights from this task regarding decision tree. And thank you very much.